Hello everybody, my name is Jay Karshbarger, and I will be explaining to you the process of performing a liquid penetrant inspection. Okay, a liquid penetrant inspection is one of the most widely used non-destructive testing methods. It is the simplest out of all the major non-destructive inspections. There's not much scientific theory behind it, and even the lowest level of trainees can perform this without difficulties. Two main reasons for its popularity: its relative ease of use, its flexibility of use, which means it can be used on a wide variety of applications, from auto parts to even the most critical aircraft components. It can be used to inspect almost any material whose surface isn't too rough or too porous. The parts or areas to be inspected needs to be prepped. This is the most important part of the inspection. The surface or the area has to be free of contaminants. If this is not done correctly, it can prevent any penetrant from entering any flaws or defects that you are looking for. If mechanical operations have been done, such as grinding, blasting, spot facing, along those lines, a caustic or acid etch is going to have to be performed due to these mechanical operations can smear any metal over the defects, and they will not be able to be picked up during the inspection. The next step is you have to apply the chemical penetrant. There's a couple different ways of applying this penetrant. You can brush it on, you can spray it on. That's not very highly recommended to spray it on because it makes quite a mess sometimes. Or you can use the method of immersion by dipping the part into the penetrant. Okay, also to remember, if you are brushing it on or dabbing it on, you need to remember, if you're doing a small area, you need to use the least amount as possible because it goes a very long way. The next step is the penetrant dwell time. You have to let this penetrant dwell on there for a certain amount of time, and that is usually recommended by the manufacturer or the specification that you're using. The penetrant needs to dwell on the surface of the part so that it can pick up any or seep into the defects that you're looking for. These times, dwell times may vary by the type of material that's being inspected, or the type of defect that you're looking for. Let's say, for example, if you're looking for cracks or if you're looking for corrosion. The next step is the removal of the excess surface penetrant. This is the delicate procedure part because you do not want to remove all of the penetrant. You want the penetrant that has seeped into any defects to stay there. There are different types of cleaning off the surface penetrant. There is the water washable way, and there is the way that you dip it in an emulsifier and then wash it, and then there is the part where you clean it off by using solvent on a rag. Do not directly spray onto the part. You spray it onto a rag and then wipe it off. The next step is you apply the developer, and this developer is used to draw out any penetrant that is entrapped in the defects. There is also a developer dwell time, usually half the length of the penetrant dwell time. This dwell time may be longer depending on what your specification is calling for. You need to refer to the specification on this time. It's usually half the time of your penetrant dwell time. And developers come in many different forms. You have your spray or aerosol form, you have your dry powder or dusting form, and you have your dipping or your wet form. Then the next step is you're going to inspect the part. This has to be done under the appropriate lighting or certain parameters. You're going to use black lights, and you have to have certain parameters. Like for that, you can only have so much white light, you can only have so much UV light, or you have to have so much UV light. Then you are going to be looking for the defects. The defects are most likely going to be small round defects, intermittent lines, and they're going to be jagged and not straight lines. Straight lines are usually surface anomalies that are not a true defect. They might be tool marks. Depending on what your specification is calling for, you are not looking for some of that. You are mainly looking for the jagged lines when it comes to cracks. When you're looking for defects, you are most likely going to have cotton swab with a little bit of solvent on the end of it, least amount as possible, because you don't want to excessively wipe away all your defect indication. You're going to wipe the defect. If it does not reappear after wiping, it is most likely not a defect. If it does not disappear at all while you do your wipe, it is most likely not rejectable. If the defect disappears and reappears, it is most likely a rejectable defect. This is due to the penetrant entrapped in the defect. It'll wipe it away off the surface, and then it'll reappear and come back out of the defect. And this is mainly what you're looking for. Okay, with that being said, then the last step is you have to clean your part. If the part was accessible and you did not fail it, then you just clean off the excess chemicals and return it to the original state. If the part was rejected, you're going to mark up the defects, and you're going to make known that the part failed. Usually it is painted red, or you write on the part that it's rejected, and you point an arrow to where the defect is. With that being said, the liquid penetrant inspection plays a vital role in finding rejectable surface defects. It's a very simple method to use when using non-destructive inspection methods, and by performing this method correctly, it helps to keep small and very large catastrophic defects or accidents from occurring. Thank you.